my name is Óbuda, and this is my official unofficial solution for the network state exam. And now it's the 16th topic, which is about transport layer, the services and functions of the transport layer in the case of the TCP IP protocol stack. So we are at the fourth layer. If we go from top or from below, so the services is quite simple. Here, if the data has been received from an above layer, so from the application, because we are using the same data through the representation session, then the data will be passed here, and this layer does segmentation and reassembling the segments, because I said it in the very early videos that the transport layer the transport layer is the layer that segments up the data to smaller chunks, because we cannot send a full disk data or a high data, because that would reserve the bandwidth that could cause slowness to the network performance, and even collisions could occur. For example, if two big data would be sent on a cable, the bandwidth would be not enough for them. Therefore, we are segmenting these data to smaller chunks and send them to the other side, and of course on the other side these will be reassembled. Also, it helps the sessions to identify which traffic goes, or which segment goes to which session, because we can have simultaneous applications on a computer that can work simultaneously or speak simultaneously. And as imagine that you would like to send an email, you would like to speak on Facebook, and you would like to see a streamed video, then it's impossible that you cannot do these together. The simple, if we wouldn't have these sessions handled, then we would be able to first send the email, then check the Facebook, then see the streaming videos, but we cannot do this simultaneously. So this is the purposes. The upper and lower interface of the fourth layer, transmission unit, header fields and their content. Of course, this is the TCP and the UDP. Both of them has a destination source port. And if I remember well, the TCP has the sequence number, the acknowledge, so maybe not acknowledge but called as flags. And both of them has some CRC or something like that, and their contents. Yeah, that's all. Compare and contrast the connection-oriented and connectionless solutions. Where do we use them? Of course, the TCP is the connection-oriented and the UDP is the connectionless. We are using TCP if we would like to get a reliable connection, say for example for HTTP, and we are using UDP when the reliableness is, or the quality is not that important. Say for example streaming videos, because there we don't care if a segment is lost, because that would be awkward if you would try to retransmit a previous frame that has already been passed. So that's why there we don't care it. So the TCP is quite important, both of them important, but the TCP is important because there a logical path will be created before the transmission. This path will be maintained during the transmission, and at the end it will be terminated. As I said, it's more reliable because it has its sequence and acknowledge approach. Therefore, it's here. If there will be a data loss, then it will be retransmitted. The data should be sent in an ordered way, and it should be reassembled in an ordered way on the other way as well. And it has a flow control or windowing mechanism as well. That means that TCP during the handshake will realize that how much resources it can send to the destination. Therefore it will not send more traffic to the destination, so there will be no flow control problem. Of course, you know, the flow control, if we sending too much data, then the receiver will not be able to receive everything. So basically that's all about the TCP, and it has a higher overhead, of course. The UDP is connectionless. That means here a logical path will not be created, maintained, and terminated at the end. Here the data will be sent, but it can come in an inordered or unordered way on the receiver side, and even the segments can lose, and as I said, it will not really care about it. But it has a low overhead, and both, it's important that both of them operating on the IP Internet Protocol, which is important. Okay. The operation characteristics of TCP/UDP, addressing formats and typical usage, connection establishment, the different phases and functions of the handshake process, the windowing mechanism. So I almost covered everything. I only have to cover the handshake if I see it. Well, so how does it look like? Let's say that this is the client and this is the server. So first there will be a client to server communication request. Client, so yeah, let's say request. So how's it going to look like? It will send a request to the client. It will have, for example, synchronization. This will be the SYN flag, because as I said, if I remember well, the TCP has flags, and it uses the synchronization flag to connect, and this will be the sequence number 100. The sequence numbers are generated randomly. The client will acknowledge the sequence number and the 100, or no, it will acknowledge the 101 because that's the next one. So it will send back the sequence number acknowledgement, this, to the client, where the sequence number will be 101, and the client will simply acknowledge it. Of course, the server will have its own sequence number, which will be 300 if I remember well, and the client will acknowledge 301, and in this case there will be, this is the handshake process. They changed every information during this process, and basically that's all about it. After this, of course, we have a connection, and how, for example, the termination looks like. Termination is quite simple. We have the client, we have the server. The client will tell that, will send a finish flag that, hey, I finished my data, I will not send more. The server will acknowledge it. The server will send its own finish flag as well, and the client will acknowledge that finish as well. Therefore, in this case, the path will be terminated, and in this case, the path will be created. If there will be if something will happen during this pause during the transmission, then so it will be discarded, or will something happen, then it will be recreated again. And basically that's all about it. I'm going to talk about the ports in the next topic, so I believe you can talk about the ports in this topic, but please check that video. So again, if I said something wrong, then I don't really care, and don't forget to subscribe to my channel.